Running Doom in virtually every device that can display pixels has always been a thing. MacBook touch bars, ATMs, or even pregnancy tests. But what about Grafana? Can Grafana run Doom? Hey everyone, my name is Kostas, and today I'm going to share with you how we answered the question if Grafana can run Doom. Spoiler alert, the answer is yes, it does. So, as a preface, this project was part of a hackathon that me and two colleagues of mine, Thomas and Bogdan, did. And we were thinking that we wanted to do something with games, and we're also using Grafana, and we saw a very interesting project from Jacob Colvin, which was rendering videos with Grafana, and it was a good way to recall your colleagues. And we thought this is a great idea. We can do something with it. At this point, you might be wondering why. Why would you want to do that? How does running a game from 1993 in a graph panel can actually benefit Grafana? But the idea was to push the time series charts to its limits and see how much data it can handle. Try out a new feature of Grafana, which is streaming data sources. And also because hackathons are meant to be fun and building unconventional things outside of your comfort zone. So how do we do it? Initially, we had two ideas. The first one being running a WebAssembly version of Doom into a browser, which would get the pixel data from, and then we would transform it into Grafana-friendly data. And the other one was running the binary somewhere else and doing all the calculations so that we have Grafana-ready data and streaming them over the wire with either WebSockets or whatever. The second option was disqualified because it required a lot of C code and a lot of bandwidth. So we went for the WebAssembly, and how does it work? We used a fork of Chocolate Doom called WebSockets Doom, which is basically a version of Doom that is compiled for WebSockets. And we modified the source a bit so that we get in-game metrics with some C code, and it invokes some ECMAScript code directly into the data source. And the way we render the game is we get the pixel data from the WebGL buffer, and we use a transformation algorithm that then it's used to display the game into the graph. So the frame is actually 320 by 200 pixels, and every pixel is a 4-dimensional vector that has the pixel data, which is red, green, blue, and alpha. So we have basically a 64. We have a 320 by 200 two-dimensional array of 4-dimensional vectors. So how do we get from the 4-dimensional space into a time series space, which is what Grafana wants. The clue here is that Doom actually uses a 256 fixed color palette, in which every color has an index. And given that palette, we can assign each color of it to a time series and assign this specific color to this time series. So every time we get some pixel data, what we do is we create a new data point at a specific offset based on where this pixel is, and we assign it to a specific series based on its color value. But there is a small problem. Grafana actually uses more than one palette. So we have the main palette, and we also have some other ones that are used basically for when the game is tinted. So for example, when you take damage or when you pick up raids. So because we found out that 256 was kind of time series was kind of a hard limit, we decided to use just one palette. And when we can't find the color, we use a red min approximation to find the closest neighbor of the palette that we're using, and the results were pretty nice. So what did we learn out of this? So we learned that we should always keep the fields for the time series constant and only update the values. Mutated the field cause expensive chart configuration updates. When assembling buffers, always use fixed length arrays instead of constructing with array push. It's better if you use explicit min and max thresholds because computing them on the fly is expensive, especially for these large data sets. And you should push new data frames in the streaming data source with a request animation frame. And the small trick that we did to increase the rendering performance of the graph was to enable the out of process rasterization. And we were able to get 256 active series with 64K data points rendered at 50 frames per second almost. So you can actually try Doomfana, both with full and half resolution, if for better performance. And that was it for us. And thank you.
This week, Atif and I built a drone control dashboard that lets you fly and monitor a drone all in Grafana. Let's check it out. Oh hey, my name is Nathan Mars and I'm excited to co-present Grafana Takes Flight. Our purpose here was creating a ground control dashboard for remote monitoring and operation all within Grafana. We believe that Grafana is uniquely positioned to be a critical tool in physical world observability, and this project showcases the potential of what could be in store. First, let's take a look at how we created the drone flight simulator dashboard. We used an open source simulator called Weebots to simulate a DJI Mavic Pro 2 drone. We used the Grafana Live pipeline to ingest the real-time sensor data from our simulated drone and visualize that data using a custom canvas panel for the telemetry, a text HTML panel for the video feed, and the geomap panel for the live location. We also added write capabilities using buttons on our canvas panel to control the drone movements and perform other pre-programmed actions like taking a picture. So, what problem are we addressing here? Currently, for huge software infrastructure deployments, there exists a number of analytics and monitoring tools, including the legendary Grafana stack, which have helped several businesses scale confidently. However, the world of hardware has not benefited from such open source technologies. Currently, there exists no such software tools that are plug and play for even the most basic monitoring and remote control tasks for robotics and industrial deployments, which are the bulk of the hardware market in need of such tools. So, what are some applications where Grafana can create value in the world of hardware? Let's take Amazon delivery drones, for example. Grafana's open source stack would be a perfect fit for monitoring and controlling a remote fleet of drones within a specific service zone. Self-driving vehicle fleets like that of Tesla or Waymo could benefit from the data logging capabilities in terms of telemetry and video footage when something goes wrong on long-haul journeys. Finally, connecting equipment from within industrial facilities to the cloud is another compelling application of providing business intelligence. In the grand scheme of things, this capability of flying a single drone and taking a picture can be easily extended to a whole fleet of drones, or frankly any robotic platform. In essence, this would position Grafana as a ground control station software. At the end of the day, we envision Grafana as not only a world-class tool for software monitoring, but also a world-class tool for real-world hardware monitoring. Atif and I are excited to expand Grafana into new and exciting applications. We hope you share our excitement into expanding Grafana Labs into the world of hardware. We appreciate your time.
Hello, everybody, and welcome to GrafanaCon 2022. My name is David Kim, and I'm here to talk you through our past hackathon project titled GeoTrek. It had recently made it into the semifinal round this past April, and I'm really excited to share what we were able to accomplish within that week. Going over the agenda, we'll be going over our team, context and inspiration, some useful examples, as well as a panel demo by Stephanie herself. Our team was composed of 3 software engineers, myself, Stephanie Clausen, and Tabor Henderson. I'm an engineer on the Grafana incident team, which is still in the early development phase, but shameless plug, keep a lookout for its progress. This is especially true if you're interested in an incident management tool that'll tie really nicely with the core Grafana prog line. Stephanie is another software engineer on the metrics team, and she's going to show us a quick demo later. It'll cover her experience with what the panel is capable of in its current state, as well as her hobbyist hiking journey in this specific case. Tabor was also a big contributor to the project and had some really cool paragliding data to share, but unfortunately, he couldn't join us for this talk. For some background of how GeoTrek came about, our group was very interested in visualizing the data we had collected from our hobbies. Stephanie is an avid hiker who enjoys spending time with her family. Tabor is a paragliding enthusiast, and I personally am a big snowboarder. These are all areas where elevation is obviously a data point which is much more interesting in a 3D space. Prior to our panel, there wasn't a really good way to see this information in a geospatial setting, let alone a 3D manner. We had a healthy amount of data collected from both Tabor and Stephanie's activities via the Strava app and saw an opportunity to expand the core product. There's only so much insight you can really gather from exploring the 2D domain, but this doesn't mean we have to only rely on the 3D data either. Together, they play a big role in understanding the data we collect on a daily basis. And on to some valuable use cases that could be achieved using this panel. As I had previously mentioned, the business intelligence space is a valuable market that the Grafana could touch. Using our panel, you can create a 3D heat map instead of a standard 2D representation. You can see already from this example the amount of data that is highlighted right off the bat. When you look at a standard heat map, the information can get easily muddled by neighboring data points, and this representation makes it very obvious where we need to focus. Not to mention, this has a bigger wow factor for anyone viewing data. As Grafana fits very many use cases already, this is another item that could fit in the engineering toolbox. Logistical analysis is another space where the value is very apparent. In this example, we include 3D models, but on top of that, we can see the flow of traffic in relation to a specific time. There's just more context to the information that is visible right off the bat. So if you're a professional trying to dive into the logistical processes involved in city infrastructure, this would be a useful representation when making an argument for any data presentation. I personally have experience in the construction industry managing 3D models and logistics. It was always a much more productive experience to utilize 3D models to understand the construction process when interfacing with other clients. With a bit of work, our panel could be able to support all of these use cases. You could even go as far as bringing in point clouds into this panel. After all, that's just another form of 3D data. Just imagine what could be possible with all this data at the palm of your hands within a single Grafana dashboard. There are many applications where 2D data is insufficient in getting a deeper understanding of what is actually happening. In particular, geospatial data is a domain where 3D data exceeds 2D data in highlighting important key details. So if you're keen on seeing something like this, implement it in the core Grafana product, join our Grafana community Slack channel and show your interest. I'm going to be handing this presentation off to Stephanie now.
Thanks, David. So everyone, my name is Stephanie Clausen, and like David mentioned, I am a software developer on our metrics team for observability. And at the last hackathon, we wrote the GeoTrack panel, and I'm here to introduce it. So I'm just going to start off by showing you the configuration. I've got some data loaded up already, and I'm going to do a quick demo. So we're using Mapbox. That means we have to have a Mapbox API token, but essentially we have a base layer. And then we have one or more layers on top of that. And then we have a terrain layer. So I can get rid of the terrain layer if I want by just getting rid of that. And there the terrain layer goes. And I'll just stick it back in. And then I've got a line layer, and that's the Squamish layer that I've called it. And essentially, this is a race run by my son and I called Squamish 50K. And let me show you, because the whole purpose of any panel is to generate insights. Just getting the data is not enough. Grafana generates insights, and that leads to actions. And that's the important part of the process. Here we are at the finish line. This is what it was like to cross the finish line. It felt really good. So it was 9 hours, 50 minutes. I've requested 10 hours of data. And as you can see here, we've got a fully 3D panel. Finish line is start line is here, and then finish line is over here. So what does this mean? Well, essentially, at the start line, you'll notice that everything is white because I put a gradient up. And the lighter the colors, the higher my heart rate. So what I'm learning by looking at this is that I totally ran out of steam near the end of the race because it starts getting all dark and gray here. 151 is my heart rate, 151 here as well, 130, 154. So I really got some fatigue by the end of the race and really worked hard here. 171, probably like 180 up here. Oh, 171, 177. Okay, so, and then over here, we've got some live data, and it's just on replay right now. So you could see, my son and I as we progress through the race in real time. And it's just on a replay over and over and over again, just so we could get the data quantity. All right, let's go to something else so I can show you. And this is the paragliding data that Tabor came up with. And this is being read from a Google Sheet, the GPS data. And essentially, in this case, we have a number of people who did the paragliding competition. And this is a way that you can sort of analyze performance between different routes. Now, this would be useful in a lot of different situations, like fleet management. I think this is a really good case for the GeoTrack panel, in that you'd be able to sort of see, as your fleet is moving around, in real time, what pressures are, maybe what engine load is, this kind of stuff. All right, so here we are. This is kind of at the end where everybody's sit down right around here. And if we zoom out, we can see this long distance that they've started from here. There's about 250,000 points being rendered in this case from the Google Sheet. So here they are at the mountain. They set off, and here's everybody kind of following the route. As I understand it, and what Tabor has taught me, is that these like loops here are where people found updrafts, competitors found updrafts. So right here you can see a couple of competitors found some updrafts here, but they didn't find them here. So a great way to look at performance given multiple tracks, and those tracks are defined right here in the data and in the panel configuration. We opted for JSON so that we could harness the power of it without having to spend a lot of time doing configuration. Anyway, so we've got one set there, one set there, one set there, and the last set there. So there we have it. Hope you enjoyed the tour of the GeoTrack panel, and hope you will all be generating insights from your enriched geospatial data in the future. Thank you.